right, so here's your lesson on vectors. They're not going to ask you any questions just specifically on vectors on the AP exam. What they're going to ask you to do are motion problems and derivatives and integrals with vectors. But you have to learn what a vector is before you can do derivatives and integrals with them. So this lesson is just on vectors and what they are and kind of getting comfortable with the notation. So a directed line segment would be something like PQ. It's like from back in geometry. Remember when you did like segments and rays? It would just be a ray from P to Q. It's basically saying like from here to there, your directed line segment. When you see this notation with these double bars around it, that means the length or the magnitude of the vector. And so it's just the distance from here to here. And so again, reviewing from geometry, this is your distance formula. It's a big square root. You subtract your X values and square it, and then you subtract your Y values and square it. That is your distance formula. I know it feels like a million years since you took geometry, but like reach back deep into your brain. That's what the formula you use for distance in geometry. So from here to here. So a vector is going to be written like that, V with a little line over, or like you'll just see it written in bold font. It is the set of all equivalent directed line segments. So like if you had one going like this, and then one over here going like this, looks like arrows being shot somewhere, one going like this. But they all have the same length and direction. Sort of like instructions for how to get somewhere. Like we're starting here, we're going there. So to use this as an example, we have V going from this point to this point and U going from this point to this point, show that they're equivalent. So we have to show that they have the same length and direction. So the distance is the same and that they're headed the same way. So first, let's do the magnitude for V. And again, we're just using this formula here. It's a great big square root. We're going to subtract the X values, 3 minus 0, and square it. Subtract the Y values, 2 minus 0, and square it. Let's see, that's going to be 9 plus 4, so square root of 13. And then we're going to do the same thing for U. So great big square root, subtract the X's. So 4 minus 1 squared, and then 4 minus 2 squared for the Y values. So this would be 3 squared is 9, this would be 2 squared is 4. So again, square root of 13. And so they have the same length. So to show that they have the same direction, we're going to look at the slopes. So we're going to look at the slope of V. So subtract your Y values. And then on the bottom, subtract your X values. So 2/3 is that slope. And then the slope of U, same thing, subtract your Y values, subtract your X values, and it comes out to 2/3. So this shows that they have, well, that's a great swirly bracket there, that they have the same direction. So they're the same length and they're headed the same way. And if you wanted a visual, like if you wanted to actually draw them, like this one starts at 0, 0 and goes to 3, 2. So it would look like that. And then this one starts at 1, 2 and goes to 4, 4. I mean, my grid isn't perfect, but that's a little visual for you to help you see it. All right, so component form, I kind of wrote too big for this one, is going to be written with these kind of like pointy brackets, V1, comma, V2. And the other way you'll see it, I don't tend to write it this way. This is like personal preference. You have to see what you like. But you'll see that first value with an I, and then plus that second value with a J. That means the same thing. So if you see that, it's just a vector in its component form. So component form means that the initial point is the origin. So it just means that it's going to start at 0, 0. And so the terminal point, which means where it ends, is, these two values, V1, comma, V2. So component form just means it starts at the origin. So for any other, directed line segment, to find that, you would just subtract the values. So you'd have Q1 minus P1, and then Q2 minus P2. If you just subtract them, that's going to give you what it would be if you started at the origin. All right. The magnitude for this, it's the exact same thing as right here. But if these values are 0, like if one of the points is 0, kind of like this one was right here. And like you can see that here, it's kind of like, why did we even bother writing that if it was nothing? You can just do V1 squared plus V2 squared. It's not a different formula. It's the exact same thing. It's just that one of the points was 0. And so that's called the norm of V. But it's just the magnitude. It's just the length from there to there, where you started to where you ended up. It's just you started at the origin. And then this is kind of cool. If that magnitude equals 1, then V is called a unit vector. And that point is on the unit circle, which is just kind of cool. If the magnitude is 1, from the origin to wherever you're going, if that length is 1, then your point ends up being on the unit circle, which is just kind of. All right, so find a component form and the length of V from this point to this point. All right, so to get the component form, again, you're just going to subtract the values. So subtracting the x's, you'd have -2 minus 3, that would be -5. And then subtract the y's, 5 minus -7 would give you 12. So if you start at the origin, you go, left 5 and up 12, you would go like this. And the other way you'll see that sometimes is -5i plus 12j. Again, I don't particularly like writing it that way, but if you do, that's fine. It means the exact same thing. And then it said also find the length, so the magnitude of that. So square root will be -5 squared plus 12 squared. So that'll be underneath there, 25 plus 144. So that's going to be, let's see, 169. And so that's 13. So if you wanted a visual of this, again, I just always like to see a picture so I can see what's going on. 4, 5. So here's -5, 12, starting at the origin. It's going to go like this. And then if you look at the right triangle that gets formed, I know my picture is not very good here, but we went left 5 and then up 12, and it's a 5, 12, 13 triangle. So it's one of those Pythagorean triples. All right, so if we get a component form vector, -1, 3, it means you go, -1 in the x direction and then up 3 in the y direction. Vectors are kind of like instructions for like how you're going for x and y. So we're going -1 for x, +3 for y. An initial point of 4, 2, what's the terminal point? Well, all you have to do is basically follow these directions. If you start here, you went -1 in the x direction, so 4 minus 1 would give you 3. And then you went +3 in the y direction, so 2 plus 3 would give you 5. So if you start here and basically follow those instructions, you're going to end up at 3, 5. That's all that is. I'm not going to read through all of this. I copied this out of the textbook. They're just vector operations. All it says is you can add them together, you can scale them by something, you can multiply them. They follow the commutative property and the associative property, and you can distribute them. Basically what we're about to do on the other side, but it's all basically common sense. They give you these two vectors. For letter A, it says do 1/2 of V. Literally all you're going to do is half of these values. So half of -2 would be -1, and then this would be 5/2 or 2.5. You're just doing half of that. It's not a very good 5, only 6 points. All right, here we're going to subtract them. So U minus V. So 3 minus -2 would be 5. And then 4 minus 5 would give you -1. All right, and then this one, V plus 2U. So that would be -2 plus 2 times this would be 6. So -2 plus 6 would be 4. And then V plus 2 times 4 would be 8. So 5 plus 8 would be 13. All right, and then we're going to play around with the unit vectors for just a minute because I think that they're cool. All right, to find a unit vector in the same direction as v, you take v and divide it by the magnitude. So to find the unit vector in the same direction as this, we're going to find the magnitude and then divide by that. So big square root, we're going to have 3 squared plus 12 squared underneath of there. So that would be square root of 9 plus 144. So that's going to be 153. I do want to split that up though. I think that'll divide. Hold on 1 second. Let me grab my calculator quick. Yeah, it'll divide by 9. So 9 times 17. And so it's 3 square root of 17. All right, so to get our unit vector that's in the same direction, we're going to take this 312, and divide by the magnitude. So divide by that 3 square root of 17. So 3 divided by 3, that would cancel. We'll just have 1 over square root of 17. And no, you don't need to rationalize it. If you really wanted to, you could write square root of 17 over 17, but that's not necessary. All right, and then divide for the 12. 12 divided by 3 would be 4. So 4 over square root of 17. But let me show you what we actually did there. Again, I just always like a visual. All right, so if you think of this vector, we went 3 in the x direction and then 12 in the y direction. It's going to be somewhere up here. So it did something like that. So here's 3, this is 12, and then this is 3 square root of 17. We wanted to find a vector going in that same direction, but where this hypotenuse would only be 1 unit. And so that's what we found here. If you have 1 over square root of 17, and then this is 4 over square root of 17, we forced this to be 1. And just to prove it to you, if you still don't believe me, if you do Pythagorean theorem for this, a squared plus b squared equals c squared, it will come out to be true. If you square this, you would get 1/17. If you square this, you would get 16/17. 1 squared is 1, and that is in fact true. So that's what we did. We found a vector going, and my pictures aren't great, they don't look like they're going the same direction, but we found a vector going in the same direction as this one, except we forced this to be 1 unit, is what we did there. This is kind of backwards. We're going to find, instead of being given that vector, we're going to find a vector with a magnitude of 9. So like we want this to be 9 in the same direction as going left 1 and up 2, basically. All right, so first let's find the unit vector. So exactly what we did right here. So let's see, we want, actually I'm gonna have to draw a triangle for this one. We want to go left 1 and up 2. So I'm going to need to do Pythagorean theorem to get this right here. So that would be 1 plus 4 equals c squared. So that's going to be 5. This is going to be square root of 5. So if we take that and divide by the magnitude, that's going to give us our unit vector. So it would be -1 over square root of 5, and then 2 over square root of 5. So again, you just find the magnitude, that's this right here, and divide by it, and that's going to give you your unit vector. Now we wanted this to be 9. We wanted this amount to be 9. So we're going to just scale this by 9. So just multiply it by 9. So it would be -9 over square root of 5, and then 18 over square root of 5. And that is our answer. So again, to show you what we did, we made this -9 over square root of 5, and this is 18 over square root of 5. And if you do Pythagorean theorem, you will get that this is 9. If you don't believe me, you can work it out. If you do Pythagorean theorem, you're going to get 9 for this. So we forced that magnitude to be 9 and made it go in this same direction. All right, this is the same thing as number 6, except instead of being given the vector, we're given the angle. I just like doing these because it's a whole bunch of trig. Same thing, we're going to do the unit vector first. 5 pi over 6 is in the second quadrant. Reference angle is pi over 6. This would be 1/2. This would be negative square root of 3/2. And because it's already on the unit circle, this would be 1. So this is our unit vector. Negative square root of 3/2, 1/2. So this one, we had to divide by that square root of 5. This one, because it's already on the unit circle, we didn't even have to do that. All right, and then we're just going to multiply that by 2. So we want the magnitude to be 2. So if you multiply, basically the 2's are just going to cancel. If you multiply this by 2, you're going to get negative square root of 3 and then 1. And so again, what we found is a vector going in this same direction, but with a magnitude of 2.